just a little background regarding this webinar. The purpose of this webinar is that we want to provide some information that may not necessarily be spelled out prescriptively in the code, and gives you also some supporting information for when people are reviewing the mass timber projects or designing mass timber projects. So this presentation goes beyond, sometimes beyond what's in the code, and gives you some scientific background on what we've done and seen in the industry. And so I'm the warm-up act for Bob Lechty. He'll provide information related to connections and durability and hydrogen embrittlement, etc. And actually, this presentation, my part of the presentation, is about an hour long, not 45. But we'll proceed through this. And if you have any questions, as Maria mentioned, please type them in the chat box, or actually the Q&A box. Okay, so you have the learning objectives, which I won't go into in detail. How this presentation is going to progress is we're going to talk about fire protection and connections. And then we'll talk about seismic deformation. And then I'll hand it off to Bob after our 5-minute break, who will be talking about durability and hydrogen embrittlement. So fire protection and connections, I assume all of you, or most of you in the audience, are engineers. And fire protection is not necessarily something that engineers get involved with. Now, for the basis of this presentation, I should have started with this first, is most of it's going to be about the 2021 IBC, which actually adopts the 2018 NDS. That's right, the 2018. And then we have the 2021 wind and seismic provisions. And that's the thing to remember about American Wood Council, is as they progress, they are going to be doing things every 3 years, but they're alternating between the NDS and the wind and seismic provisions. So the 2024 now has the 2024 NDS and the 2021 wind and seismic provisions. So getting back to why are we talking about fire resistance and how that relates to mass timber? Well, one, a lot of the projects that I've seen moving forward, people aren't familiar with mass timber. They're wondering why it costs so much. And so the areas that engineers can impact is the fiber, and that means the size of the mass timber elements. And that means that fiber, the more fiber you have, the more costs. So anywhere where we can reduce the budget of the project is really in the fiber. That's the one area that engineers can have an impact on. And believe it or not, connections can have a direct impact on fiber. And it has to do with fire resistance and how much we need to build up our mass timber elements to meet the fire requirements.